In this section of the video, we're going to go over the basics of binary numbers. Now, we're not going to go into great depths. We're going to go about as far as we need to in order to do subnet calculations. So, binary, as you're aware, is simply ones and zeros, whereas in our decimal notation, we have 0 through 9 as the characters that we encode numbers in. So if we want to convert from decimal to binary, here's how we go about it. So if we have the decimal number 1, that's simply the binary number 1. If we have the decimal number 2, well, that's the binary number of 1, 0. Well, how does that work? How does that work conceptually? This is how I think about it. Hopefully that's helpful to you. Now we have down here, we have our number scale. And so we have here 2 to the 0 power is actually 1, 2 to the first is 2, 2 to the second is 4, and so on, up to 2 to the 7th, which is 128. Now when we're doing subnet calculations, the biggest numbers we have to ever worry about with IP version 4 is 255, just because we break out our octets like that. So we're only going to worry about numbers up to between 0 and 255 for this case. So let's say we wanted to take the number 2 and we wanted to actually manually go through the calculations rather than letting Excel do it for us. Manually calculate, okay, what is 2 in binary? So here's what we do. We look at this little chart and we say, okay, well, the number 2, is that bigger than 128? Well, the answer is no, it's not. Is it bigger than 64? No, it's not. Bigger or than or equal to 32? Nope. Greater than or equal to 16? Nope. 8? Nope. 4? Nope. 2? Yeah, it's equal to 2. And we subtract our 2 from that value, and we're left with 0, so we have 0. That's how we ended up calculating it. So let's do a couple bigger numbers to try to illustrate that concept a little bit more as we're converting from decimal to binary, so just so we can understand the concept. So let's say we were wanting to calculate, let's do 54. So we're going to calculate 54. Now Excel obviously will spit out this this binary number automatically for us with our with the function I put in there. But let's go and do it manually. So we'll clear all of these, and let's go through and walk through how the calculations are done. So the number 54, is it greater than or equal to 128? The answer is no. Is it greater than or equal to 64? Well, the answer is no there as well. Is it greater than or equal to 32? Well, the answer in that case is yes. Okay, so that value becomes a 1. And then we need to subtract 32 from the 54 value, which gives us 22. So then we go to the next value and say, okay, is 22, our remainder, is that greater than 16? In that case, the answer is yes. Okay, 22 is greater than 16, which gives us a remainder of 22 minus 16. That gives us a remainder of 6. Is 6 greater than or equal to 8? The answer is no. Is it greater than or equal to 4? The answer is yes. We do 6 minus 4. Our remainder is 2. Oh, is 2 greater than or equal to 2? Yep, it's equal to 2. And then finally, we're left with the remainder of 0. And so that's how we calculate the number 54. Let's do a couple more numbers, and hopefully this will kind of settle you on how we convert from decimal to binary conceptually. Let's do the number, let's do 149, and let's do it before we actually put it into Excel so we can see if we got it right. So we're trying to do the number 149. Number 149, is that greater than or equal to 128? The answer is yes, it is. And so if we subtract 128 from 149, we're left with a remainder of 21. Is that greater than or equal to 64? Nope. Greater than or equal to 32? Nope. Greater than or equal to 16? Yes. So 21 minus 16 gives us a remainder of 5, which is less than 8. Greater than 4. We subtract our 4 out. That gives us a remainder of 1. And we end up with that. So let's check our values. Hopefully we're right. And we should have 1, 0, 0, 1, 0, 1, 0, 1. Okay, cool. Let's do one last one. Let's do 255. So 255 is a special one, actually. We'll see in just a second. Is that greater than 128? The answer is yes. If we subtract 128 from 255, we actually get 127. So is 127 greater than 64? Yes. We subtract that out and we get 127 minus 64 is 63. Is that greater than 32? Yes, it is. 63 minus 32 is 31. Is that greater than 16? Yes, it is. 31 minus 16 gives us 15. Is 15 greater than 8? Yes, it is. 15 minus 8 gives us 7. Is that greater than 4? Yep. 7 minus 4 gives us 3. Greater than 2? Yep. 3 minus 2 gives us 1, and we have a remainder of 1. And so 255 is actually all ones, 8 characters, or 8 digits of all 1. It's the largest number that you can represent with 8 binary digits. And because we break our IP addresses into octets, or a series of 4 pairs of 8 digits, the biggest number in any single octet can be a 255, whereas the smallest number can be a 0. All right, well, hopefully that gives you at least a little bit of basics of converting decimal to binary. Now, if you want to convert the other way around, then it's simply kind of doing the opposite approach. So in this case, we would say, okay, well, let's take, how many, do we have a 1? Yes, okay, we have a 1. We'll add 1. Do we have a 2? Yes, so we add those together. 1 plus 2 gives us 3. Do we have a 4? Yes, that, 1 plus 2 plus 4 gives us 7, and so on until we get up to, in this case, 255. For a simpler number, like let's say we did 54 earlier. 54 was 0, 0, 1, 1, 0, 1, 1, 0. We can go and we can say, okay, is there a 1? Nope, there's not. This is going to be an even number. Is there a 2? Yes, there is. So we'll add 2 to the 4 that's right here. That gives us 6. We'll add that to 16. That's 22. We'll add that to our 32. And, oh, we're up to 54. That's how you convert backwards. So conceptually, that's how it works. And then in the next section, we'll talk about actually calculating subnets, which gets much more fun.